Hey there, I'm a materials engineering student, and today I want to talk to you about something that's been making waves lately: deep sea mining. It's a hot topic right now. Some people think it's risky because it could impact the ecosystems of the ocean in ways we don't fully understand yet. But others think it's still a better choice than tearing up more land to get the materials we need. Let's take a deeper look. This right here, this is where I took my very first materials course, and I still remember hearing this one quote that stood out to me. We are living in a material war. And yes, Madonna said that. Turns out, she wasn't wrong. You see everything around us. The brand new library structure, the street we walk on every day, even the devices we use from morning till night, such as the very device you are using to watch this video. They are all made of materials. So where do all these materials come from? Let's take a look. They are still used in that new library. It's shipped from other states. Minnesota, for example, produces about 75 to 85% of the entire United States iron needs per year. Pay attention to the surrounding area, see if you notice any difference. Another example is the sidewalks that we walk on every day. That's concrete, and the materials for that are mined just a couple hundred miles away. Those devices that we use constantly, our phones, our laptops, they might be designed in Silicon Valley, but the raw materials, they come from all over the planet. A lot of them are sourced from mining operations in China, which supplies 60 to 70% of the global market. And then there is a whole different world out there, underwater mining. In the Clarion-Clipperton Zone, way out in the Pacific, you will find massive polymetallic nodules, packed with nickel, copper, manganese, and cobalt. And off the coast of the New Guinea, there is Solwara 1, a seabed site loaded with rich sulfide deposits. It's having gold, copper, zinc, and silver just sitting there, waiting. So let's take a moment to recap. Lately, deep sea mining has become a major topic of debate. While the general public is skeptical, which is fair and understandable, some of the world's leading scientists and oceanographers believe it might actually be a better alternative than tearing up more land to meet our growing demand for material. What do you think? No matter what your background is or what field you are in, we all share this beautiful blue little planet. This is our home, and how we choose to take care of it, that's something we all have a voice in. Alright, let's dive deeper. How does land mining work? There are two main methods: open pit mining and underground mining. Open pit mining strips away all topsoil, trees and vegetation, leaving a massive environmental footprint. Underground mining may look less destructive, but it causes habitat loss, air and water pollution, land subsidence, and groundwater contamination. In Ethiopia, for example, a small-scale mining has led to widespread deforestation and water pollution. A global study of over 3,000 environmental conflicts shows that mining often leads to land loss for indigenous communities, deforestation, and disappearing livelihoods. The Oak Teddy mine in New Guinea is a striking example. It dumps 80 million tons of waste into the rivers each year, causing 1,300 square kilometers of deforestation, about the size of Sequoia National Forest. Imagine losing a Sequoia National Forest each year. Now let's look at a proposed alternative: deep sea mining. There are three types, but I'll focus on the Clarion-Clipperton Zone, which is one of the most studied mining regions. Here, companies use hydraulic suction systems. Underwater robots collect polymetallic nodules and pump them up to the ship. But it's not just the nodules being removed. These machines disturb the seafloor, pulling up sediments and marine life. That sediment is then discharged mid-water, right into the twilight zone where many deep-sea organisms live. This murky water can impair vision-based feeding, clog gills, and reduce light, disturbing vertical migration and oceanic carbon cycling. Worse, sediments may contain heavy metals, which can build up through the food chain, even reaching humans. But there is hope. New technology is being tested. Robotic arms, for example, are used instead of scrappers to reduce sediment plumes. The suction nozzle is raised, which can cut sediment disturbance by up to 70%. And real-time monitoring, letting operators adjust equipment to minimize harm on the fly. In conclusion, we are not choosing between good and bad. It's often bad versus worse. Even our textbook can mislead us, like the claim that most species live in the ocean. That's actually a false claim. When we evaluate the future of mining, we must weigh the trade-offs honestly. With a strong regulation, innovation, and ecological responsibility, deep-sea mining might become a more sustainable alternative to land-based extraction. I hope you learned something new today, and thank you for becoming better informed.